Sometimes there's a mystery detectives cannot solve. Their problems only multiply, solutions just evolve. And then comes the great divide that splits things all apart. Then you need the master, a man with math and heart. He's Abacus the Great, he'll clear up all suspicion. He'll distribute, regroup, solve for X, cause he's a math magician. Add, subtract, multiply, divide, all things which he excels. Polygons, fractions, a man of many spells. The steps are simple, one by one, the numbers infinite. For help in math, both big and small, call Abacus the Great! Hello, apprentices, and welcome back to another bewildering episode of Abacus the Great! This week, we're going to review last week's magic trick, as well as extend last week's lesson on properties as we discuss the distributive property. Before we get to any of our fun, let's take it away with Helix and this week's song.
The distributive property helps distribute, hurrah, hurrah. The distributive property helps distribute, hurrah, hurrah. Distribute means that you take a number and multiply by each the other numbers, then add, and your answer is the same. Boom, boom, boom. The distributive property helps distribute, hurrah, hurrah. The distributive property helps distribute, hurrah, hurrah. If you add the numbers in parentheses and multiply by what's outside, your answer should be 120. Show your work, so your answer is correct. Boom, boom, boom. The distributive property helps distribute, hurrah, hurrah. The distributive property helps distribute, hurrah, hurrah. If you distribute first, then add the product, your answer should be the same as when you did it the other way. Like at first, multiply, boom, boom, boom. The distributive property helps distribute, hurrah, hurrah. The distributive property helps distribute, hurrah, hurrah. Distribute means that you take a number and multiply by each the other numbers, then add, and your answer is the same. Boom, 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 boom.
Stellar as always, Helix. Let's start off by taking a look at last week's apprentice sent-in magic trick. Let's see if you were able to figure out what their trick was. Now, if you recall the magic trick from last week, apprentice Annika did the magic trick where she turned 10 plus 9, which is 19, and proved to us that 10 plus 9 actually equals 21. She did the following steps if you look right over there. She separated the 10 into 5 multiply 2 and the 9 into 3 multiply 3. She then used the commutative property to switch that 2 and that 3. So we have 5 multiply 3, add 2 multiply 3. This is 15 add 6, which is 21. Now, did you take a time to think about it this week? Did you figure out what the magic trick was in that? Let me circle it for you right over there. The switching of the 2 plus 3 to 3 plus 2 is not really possible in the practical mathematical world. The commutative property, which she used to switch that, is all fine and dandy, except for the order of the operations take precedence. So we have to multiply before we add, which means we have to multiply before we can switch those two numbers. So you would have to do the 5 times 2 is 10 and the 3 times 3 is 9. And then you could switch them to 9 plus 10, which is still 19. It's an excellent, excellent magic trick, Annika. Practically, doesn't work. Mathemagically, incredible. All right, If you remember last week's episode, we talked about 3 of the 4 properties: commutative, associative, and identity. This week we're going to be talking about the distributive property as was introduced to us by Helix. Let's jump into the computer and get on it. If you think back to last week's lesson, I gave each of the 3 properties I taught you a special word. Commutative was commute, which means to travel. Associative is associate, which is friends. And then identity is just kind of the mirror property. Now, we've got one of those for this week too. If you paid careful attention to Helix's song, then you should know the answer to this question. What is the root of the word distributive? Okay, the root of the word distributive is distribute, which we are going to say means to share. Let's take a look at the problem I pulled up over there. I've got 3 parentheses 5 add 2. The first thing that's important to point out is the 3 right next to the parenthesis is telling us to multiply. So that is 3 multiply 5 add 2. Now if we did this just the way it's written, our order of operations tells us that we have to do what's in the parentheses first. So 5 add 2 is 7. And then I can do 3 multiply 7, which gets us 21. But we want to focus on the distributive property this week. And distribute means to share. So, and we know that that 3 next to the parenthesis means multiply. Well, that 3 is going to share himself out. He's going to go, what is 3 times 5? So 3 multiply 5 is 15. Now, if I only multiplied by the 5, is that sharing? I mean, that little 2 is sitting over there all by himself. So we also have to do 3 multiply 2. So you're going to do 3 multiply 5, add 3 multiply 2. 3 multiply 2 is 6. And then you have that 15, add the 6, which takes us to our 21 again. Let's take a look at another one of these, and I'm going to do the 2 different ways side by side so you can compare them. Let's take a look at 8 multiply 6 plus 4. Now, if we do that following the order of operations, then we have to do the 6 add 4 first. 6 add 4 is 10, and then 8 multiply 10 is 80. If we look at this using the distributive property, that 8 needs to share itself. So I'm going to do 8 multiply 6. And then I'm going to add that to 8 multiply 4. We then move on to 8 multiply 6 is 48. And that's going to get added to 8 multiply 4, which is 32. Now we're going to add together 48 and 32. I recommend rewriting these vertically. This helps us make sure our place value is lined up like it's supposed to be. 8 add 2 is 10. So I'm going to write in my 0 and I'm going to carry my 10. 1 add 4 is 5. 5 add 3 is 8. So we still get that same 80 for our answer. Now let's take a look at what I personally think is the most important use of the distributive property. And that's being able to help you do mental math with some larger multiplication problems, like 6 multiply 23. If we split this out, you would end up having 6 multiply 20, add 3. Now, I'm going to do this for you both of the different ways side by side so you can see that again. If we just follow our order of operations, we do what's inside the parentheses first, which takes us back to the original problem before I split it out, 6 multiply 23. Now, same as the addition, I recommend rewriting this vertically because math is just a lot more clean written this direction. 3 multiply 6 is 18. We're going to carry that 10 over. 2 multiply 6 is 12. Add a 10 is 13. We end up with 138. Now, if we do this where we distribute, we're going to distribute to 6 multiply 20. And we're going to add that to the distributed 6 multiply 3. Now these are two numbers that I can add together and multiply mentally. I know that 6 multiply 2 is 12, so 6 multiply 20 is going to be 120, and 6 multiply 3 is 18. So now all I have to do is add together 120 and 18. Well, 20 add the 18 is 38, so 120 add 18 gives me the same 138 that we got the first time through. Let me do one more of these for you, and I'm going to do it mentally first so you can see what I'm talking about. And then I'll show you the work. So we're going to do 5 multiply 42. Well, 42, if we split that apart, is 40, add 2. 5 multiply 40, well, 5 times 4 is 20, so 5 multiply 40 is going to be 200. 5 multiply 2 is 10. And then I just need to add together the 200 and the 10, so I know that 5 multiply 42 is 210. Let me show you the work there so I can break it down for you what exactly I did mentally. We split apart the 40 and 2. So we have 42 is 40 plus 2. I then distributed the 5, so I had 5 multiply 40, add 5 multiply 2. 5 multiply 40 was 200. 5 multiply 2 was 10. 200 add 10 is 210. Doing these problems mentally and getting to where you can just get through them like that is going to greatly help you in the future. Splitting those numbers apart and doing the distributive property to help you with that mental math is probably the most important thing, in my opinion, that the distributive property is used for. Let's go to our student question for this week. This week's student question came to us in the form of an email from an apprentice named Thomas. He asks, "Dear Abacus, I went to the zoo the other day. I saw a monkey eat 2 bananas just while I was sitting there. If he did this 3 times a day, how many bananas does the zoo need to feed him for a week? What about a year? Thanks for everything, Abacus. Sincerely, Thomas." All right, Thomas, we will get right to this. Let's jump into the computer. So Thomas saw a monkey eat 2 bananas. If they eat this 3 times a day, how many bananas does the zoo need to feed them for a week? What about a year? First off, Thomas, you sneaky little guy, you asked 2 questions. But Abacus doesn't mind. I will answer both of them. So Thomas saw a monkey eat 2 bananas. So we start off with that 2 bananas. If they eat this 3 times a day, that means they eat 6 bananas a day. How many bananas does the zoo need to feed them for a week? So we're then going to do that 6 multiply 7, which will tell us they feed the monkeys 42 bananas in a week. I don't know about you, but I like bananas, so I think that's one lucky monkey. Now, Thomas's next question was, how much do they feed them in a year? Now, there's 2 different ways we can do this. We can either take that 42 and multiply that by the 52 weeks of the year, but I think a more precise answer would be if we took the original 6 per day and multiplied it by the 365 per day. So we'll end up having 365, and we're going to multiply that by the 6 bananas a day. 5 multiply 6 is 30. 6 multiply 6 is 36, 37, 38, 39. 3 multiply 6 is 18, 19, 20, 21. If all of these lucky monkeys ate was bananas for the entire year, 2 per sitting, 3 per day, they would eat 2,190 bananas per year. Thank you for those questions, Thomas. I appreciate it. You ready to do some math? I want you to think of a number. Any number between 1 and 9. You got it? All right. Now add 5 to that number. Add 5 to your number. Okay, now add 3. So you thought of a number, you've added 5, and now you've added 3. Now I want you to subtract your original number. You there? So you thought of a number, you added 5, you added 3, you subtracted your original number. Now multiply that by 2. One last step. You ready? Let's add 4. So you thought of a number. You added 5 to that number. You added 3 to that number. You subtracted your original number. You multiplied that by 2, and then you added 4. You got your answer? As always, so do I. Your answer is 20. That's it for this week, guys. As always, until next time, make sure your math is magical. Hey guys, I hope you enjoyed this week's episode of Abacus. If you liked what you saw, be sure to click that like button down below. If you want to stay up on future episodes, be sure to click subscribe. If you want to get in contact with me, you can do that a couple of different ways. First off, you can email me, abacusthegreat2020@gmail.com. You can email in questions like today's or whatever. Reach out. If you want to record your very own video for Abacus, then go to flipgrid.com/abacusthegreat. Once you're there, you're going to put in the code MATH. That'll bring you into the grid and you can record your questions, comments, or whatever for me. See you next time.